In this video, we're asked to get a vector sum of two vectors that are defined in polar form, and then we want to express the answer in polar form. So it might help to have names on these vectors. I'll call this one V, and I'll call this one W. And then the whole procedure for this is to break V and W into their x and y components. We use a minus sign on any x component that points to the left. We use a minus sign on any y component that points down. And then we add up all the components to find the total components of the vector sum, and then we'll use right triangle trig to express that in polar form. So we break everything into components. There's the x and y components of V, and I can see that the x component of V is going to be negative. And there's the x and y components of W, and I see that the y component of W will be negative. And so that x component of V, I'll just keep the minus sign out here in front. The magnitude of it is going to be a 10 cosine of 50 degrees, because it's the adjacent side, we use the cosine. And this gives me negative 6.428, just keeping some extra precision because we're in the middle of a calculation. Now the y component of V, that's a 10 sine of 50, and that comes out to 7.660. Then the x component of W, 6 cosine of 20 degrees, and that's 5.638. Y component of W, that's 6 sine of 20 degrees for the magnitude of it, and then I put a minus sign on it because it points down, and that's 2.052. Then we get the total x component by adding those up, and that's negative 0.790. And we'll get the total y component, and I just realized I lost a minus sign on wy, so we'll fix that real quick. And I get 5.608 for that. Next, we'll draw a triangle with this total x and total y component. And the x component points to the left, and it's rather small. The y component should be about 7 times as long as the x component. That's 5.608. And then our vector sum points from the tail of the first to the head of the second. And we'll label our angle with respect to the x-axis there. And I'll just go ahead and label the magnitude as a u. Then we get the magnitude of the vector sum using the Pythagorean theorem on this. So we take the sum of the squares of the legs and square root the result. Note that I just disappeared the minus sign on the 0.790 there because I was going to square it, and that undoes the minus sign anyway. And I get a vector magnitude of 5.66, just keeping 3 sig figs. And then this angle is the angle whose tangent is 5.608 over 0.790. Notice that I'm just working with the magnitudes of those legs there. In other words, I'm ignoring the minus sign on the 0.790. This is going to give me an angle between 0 and 90 degrees, which is the way I wanted to label it, as an angle relative to the x-axis. And I get 82.0 degrees out of this. If you enjoyed this video, or at least found it useful, check out another one by clicking one of the links on the left, or click the Zach's Lab logo on the right to explore dozens of physics and math playlists. As always, you can leave your questions, comments, and requests in the comments section below, and I'll get back to you within 24 hours. Thanks for watching Zach's Lab, and best of luck on your math and physics journey.